Hello, welcome back to Cinderella Math. Today we'll be going over using the chain rule to calculate derivatives in a Calculus 1 class. All right, I'll just be writing the problems up here, but these are typical problems that you would see in a Calculus 1 textbook. And yeah, let's work on the chain rule. Right? Example 1. Let me just check something. Where'd my... Sorry, just grab my paper here. All righty. Sorry about that. We have a function is 4x cubed minus x, all of that raised to the 10th. Okay, so chain rule, technically the definition, well, it's that we have an inner function inside of a bigger function. That's what the original problem looks like, so I'm going to call that OG. And then the derivative of that is you take the derivative of the outer function, keep the inner, times derivative of inner. Now that has always been just very difficult for me to look at and know what to do. It will make more sense when we come over to the example. So let's look at example 1. This is the inner function. So you could call this blah. I know that's kind of silly, but go with me. It's blah to the 10th. Okay, so ignore the inside and just take the derivative of that. So you would pop that down using the power rule, keep the blah, and then subtract 1, so that would be to the 9th. And then the chain rule says you do all that, and then you times the derivative of the blah. All right, now let me do it without the blah. Okay, but that's the gist. That's chain rule. Okay, so let's do that again. We're going to drop this down as we normally would. Keep the inside garbage the exact same. Subtract 1 as we normally would. Times the derivative of the inside, using power rule, would be 12x squared minus 1. And then if you can make it any prettier, we would. But that doesn't go any prettier. That's fine. Just leave it like that. Okay. I'll get you a second example here. Right. We have a function, f of t is 3t minus 2, all of that being raised to the 5th. So the derivative, do it as normal, drop that down, keep the inside, subtract 1 as normal, times the derivative of just the inside would be 3, just the inside. And now this time we can make it look prettier. Where number 1, that was as good as it could go. Here we can do 5 times 3, so 15, and then just drop the rest down. There we are. And that's chain rule. It looks scary. This definition of it looks scary. But once you actually get into it, it's not that bad. Got a couple more examples here. 3, let's do some trig. We have g of theta is sine theta plus cosine theta, all of that cubed. So again, ignore the inside for a second. Let's drop this down. So g prime would be 3. Keep the entire parenthesis as you see it. Drop that down by 1, so squared, times what is the derivative of the inside. Derivative of sine is cosine, plus derivative of cosine is negative sine. And now that plus minus just looks bad, so let's just clean that up a little bit. I would just say that's cosine minus sine instead of plus minus. And I think that's as good as she goes. It doesn't look pretty, but it's fine. And I got one more basic one here. H of t is e to the 3t squared plus t minus 1. Okay, so when you have e, you should probably already know just straight up that the derivative of e is e. So when we're doing chain rule with this, to do his derivative, it's the same exact thing that you already see. So write that same thing exactly. And then for chain rule, you're going to times the derivative of the power. So just looking at that power, the derivative would be 6t plus 1. You can leave it like that. I've seen some professors want it like this, 6t plus 1 times e, blah, 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 blah. I think it does maybe look a little better with the e in the back, but it doesn't matter. Either way is fine. Okay? All righty. Now let's do another couple. Let me see here. Some with trig, which we've already done, but these are going to be a little different. Let me just clear that. So let's look at this guy here. I forgot which example. I think I'm on 5, sorry. F of x is cosine 3x. Okay? The outer function is cosine. So we don't have a power here. This is our outer function. So when we do the derivative, take the derivative of the outer function, which derivative of cosine is going to be negative sine. Keep the inner function. So this is our g, this is our f, right? And according to chain rule, the derivative is g prime, keep the f, times f prime. So we've done g prime, keep the f, times the derivative of that inside. So the derivative of 3x is just 3. Now that's the answer. It just doesn't look good. You can just pop that right there. So negative 3 sine 3x. That's the prettiest derivative. Okay, let's try that again. Number 6. We have a function, g of x is tangent 5x. Okay, so again, tan is our outer function. So we need derivative of tan. What is that? Secant squared, I believe. So these you just want to memorize or have if you're allowed like a little cheat sheet, feel free. So derivative of tan is secant squared. Keep the inner garbage times derivative of the inner. And then that would just look better in front. So final answer there would be 5 secant squared 5x. And you always want to put that squared there, not there. Because that would look like the 5x is being squared, but it's the function secant being squared. Okay. Alrighty, I got one more trig for you. Number 7. We have h of t is sine to the 4th 2t. Okay. So the original or the outer function is sine to the 4th, and this is your inner function. So this one, I know I said not to do this, but if this helps you, you could rewrite this as sine of 2t, and then it's to the 4th, but it's sine to the 4th. So I don't know if I would rewrite that, but if you truly need to, you could. Okay. I would be more tempted to not, and then just go ahead, pop the 4, keep the sine, subtract 1, so that would be cube, keep the inner function the same, times the derivative of the inner, so 2. And then just clean that up. 4 times 2 would be 8. Sine cube 2t. Okay, but again, you could rewrite it as sine of 2t 4, as long as you remember that the 4 only applies to the sine. It does not apply to the inner. And then you could do this. Boop. So that's 4 sine of 2t cube times the derivative of the inner would be 2. 4 times 2 would be 8 sine cube 2t. And again, at the end, convert it back. See how it was written like this with the 4 right with the sign? You want the 3 right with the sign. I personally would not do that second way, but you can if that helps you catch your powers. Okay? All right, I have just a few more here. Find it. Okay. So this is going to combine a couple rules. I have a function is x squared sine 5x. So we're going to need the product rule with the chain rule on this. Let me remind you of product rule. If your original thing looks like this, f times g, so two functions multiplied, your derivative is f g prime plus g f prime. That's product. So looking back to our function, I'm going to let f be x squared and g be sine of 5x. And then I like to do what I call side work. So if f is x squared, f prime is 2x, and if g is sine 5x, now here's where we'll need a chain rule. Take the derivative of sine, so cosine, leave the inner times derivative of inner. And then that just doesn't look good, so pop that to the front. So g prime is 5 cosine 5x. And then I just scratch this one out, so I use the pretty one. And now, following the product rule, it's f g prime plus g times f prime. And then just clean this up. Right here, x squared times 5 could be 5x squared cosine of 5x. And then this would just look better if this was in front. Plus 2x times sine 5x. Nothing combines. There's no like terms. And that's your derivative. So again, that's not the prettiest, but it's fine. So that was the product rule in conjunction with the chain rule. Okay, and now I'm going to kind of kick it up one notch here. I'm going to have a function and I'm going to be given an x value. And we're going to find the equation of the tangent and the normal line to that given x value. So we actually already did the derivative of this. I think this was my very first example, but it's okay. It won't hurt us to do it again. Here's our function. And our given x value is at x equals 0. So go ahead and plug 0 into the function. So just evaluate f at 0. So that would be 4 times 0 cubed minus 0 to the 10th. So that would just be 0 to the 10th, which is 0. So when we plugged in 0, we got 0. So just go ahead, pop that in. You don't even have to show work. You could just run that through your calculator. And now take the derivative, which we already did, but let's do it one more time. Won't hurt us. Using chain rule, that would be 10, keep the inside, to the 9th, and then the derivative of the inside would be 12x squared minus 1. And that does not get prettier. I would just leave that. Now, put 0 into the derivative. So we're doing f prime evaluated at 0. That would be 10, 4 times 0 cubed minus 0 to the 9th. 12 times 0 squared minus 1. Okay, so that's 10. This inner would be 0 to the 9th. And then this would be 0 minus 1. So we have 10 times 0 times negative 1, so 0. Okay. Did I mess up there? I don't think so. So that answer, the derivative evaluated at 0, that is the slope of the tangent line. And then we have in point slope form, our formula is y minus y1 equals mx minus x1. This is x1, this is y1, and this is the slope, so this is m. So we'd have y minus 0 equals 0, x minus 0. See why I think I messed up, but I don't think I messed up. So who cares about 0? This would just be 0. Y equals 0. Let me give that a quick look in a graph real fast. Give me 1 second. I think it's fine. Just 1 second, sorry. I mean, it looks okay. Looking at a graph here on my phone. Yeah, that's right. It's fine. Okay. And now that was the tangent line. So the question that I'm looking at also wants the normal line. Remember, definition of normal line is that it is perpendicular to the tangent line. Okay, so if you remember back into high school math, probably geometry, you learned that slopes of perpendicular lines are negative reciprocals. The reciprocal of 0 is nothing. It doesn't have a reciprocal. It is undefined. So again, remembering back into high school math, an undefined is an X line. So this line that we got for our tangent line, that was just a flat horizontal line. So our normal line is just going to be a flat vertical line. So it's going to be X equals, and then going back up, what was our X value? 0. That is weird. Usually we do not get just straight horizontals and verticals, but it happens. Okay, I can show you that one on Desmos. Let me take this off for a second. Oop, okay. Grab that original problem again. Okay, that whole function was 4x cubed minus x to the 10th. Yeah, and we were looking at x equals 0. So if we zoom tight onto Desmos here, there he is. So you can see the point is 0, 0, and that tangent line would just be this straight horizontal line. So the tangent line is just straight through y equals 0. And then if we wanted to come perpendicular to that through that point, perpendicular, that would be x equals 0. There's your normal line. So again, kind of a weirdo, but it does happen. All righty. Let's see if we have one more and it's a similar situation here. Okay, I'm just going to do it right up on top of Desmos. Same directions is find the tangent and the normal lines. And again, I think we've already done this function as well, but this won't hurt us to do it again. It's 3t minus 2 all to the fifth, and we're looking at t equals 1. T is the same as x, so don't be scared by that. Let's plug that in and see what we get. So let's do the function at 1. So that would be 3 times 1 minus 2 to the fifth. So that's 3 minus 2 to the fifth. So that's 1 to the fifth, which is 1. Okay, so there's our point. And now we don't need that work anymore. Of course, you could have done that through a calculator or your head even. And now let's take the derivative, which we've already done earlier in this video. Let's do it again using chain rule. That would be 5, keep the inner, subtract 1 times derivative of the inner. So 5 times 3, this one can clean up and be 15, 3t minus 2 to the fourth. Okay, there's our derivative. And now plug in the t, normally x, it's fine. Plug in that value. So x or t right there. So we're doing the derivative evaluated at 1. That's going to be 15. 3 times 1 minus 2 to the fourth. So that's 15. 3 minus 2 to the fourth. 15, 1 to the fourth. So that's 15 times 1, which is 15. And that is the slope of the tangent line. Okay, so using point slope form, We have y minus y1 equals mx minus x1. Now I know this has t's. It's fine. It's totally fine. This is x, this is y. So we're going to have y minus 1 equals 15. We just found that. X minus 1. And then I would just move this over to get y by itself. And there you go. That is the equation of the tangent line. If you wanted to distribute, you certainly could, and you'd get 15x minus 15 plus 1, and you'd get 15x minus 14. Some people want you to, some people don't. Just do whatever your teacher wants there. Okay, and now let's do the normal line. So remember that is perpendicular to the tan line. Okay, and our slope was 15. So our perpendicular slope is going to be the negative reciprocal of that. So the reciprocal of 15 is a 15th and then negate. And now do that same formula. Y minus the y value equals m, oops, our new m, which is negative 15th, x minus the x value. And again, I would just throw that over. Y equals negative 1 15th, x minus 1 plus 1. That's our normal line. And I would not distribute there unless your teacher really wants you to, because that would be nasty fractions. I mean, it's doable, but don't unless you really have to. And that, I think, is what I wanted to do today here for chain rule and some applications. We can check this one real fast. So Desmos doesn't know t, so we'll just change that to x. Okay, there was the original function. And we were looking at the point 115. They told us the 1. We got the 15. Might need to zoom out here. Oh my gosh. Oh, there. Is that point not on the... Oh, no, no, no. We were looking at the point 11. My bad. There we go. There he is. That's on the graph. Okay. And now we got for the tangent line at that point, I just need to bring back my work, 15 x minus 1 plus 1. Before distributing, we got y equals 15 x minus 1 plus 1. Now you could distribute if you want. And does that look tangent to that point? Yeah, it does. And remember, tangent means it just smacks on at that point. And then for the normal line, we got y equals, and we did not distribute here because it was a fraction. Does that look perpendicular to it? To that original line or to the tan line? Yeah, I'd say so. Looks pretty good. That one's harder to check, but it looks fine. Is that what I got? Let me make sure. Negative 15. Yeah. Okay. Alrighty, that's going to conclude this video on chain rule. There's certainly more to chain rule, but hopefully this was a nice introduction. If you have any questions, let me know, and I hope you're having a great day. Bye-bye.